Darrell Jr. I'm doing a presentation today about doing Atari 2600 homebrew games. This photo here is just part of my collection of homebrew games. There's been over 100 homebrew games made, and I've just got a few of them here. First thing is, what is homebrew? Typically, homebrew is games written for systems that were not designed to be end-user programmed. So like computers, you got it, you could write games for it, so that's not really homebrew. There's been over 100 that have been released for the 2600. Okay, thank you. And Atari Age sells over 80 homebrew games currently. Only Atari has a larger catalog of Atari 2600 games than Atari Age. And my games, I've got 4 games that are finished. Well, technically one of them's not done. We found some space, and I've got a couple others that are in development. Medieval Mayhem's the one I'm most known for. It's been used in tournaments all over. It's actually going to be used in a tournament here. It's my updated version of Warlords. Now, I've done Space Rocks, which is an updated version of Asteroids, and that's been released this weekend at PRGE. Stay Frosty was part of the Stella Stocking. It was a 5-game compilation done in 2007. And it was just a bunch of miniature games. And then we've announced this weekend the Stay Frosty 2, the sequel to Stay Frosty, which is adding some new features, like there's new enemies. You got the birds over here. You can throw fireballs. There's presents, power-ups and stuff. So it's a full, it's more than the mini game. It's a full-blown game. This is one that I've got in process. It's Frantic. It's a combination of Berserk and Frenzy, and you can pick which version of the game. I got sidetracked and ended up writing Space Rocks first. I was working on Frantic and wondered, what could I do with all these sprites that I can make the Atari show? And ended up doing the Asteroids rewrite. And then another one is Timmy. ThinkGeek contacted me at the start of the year. They were wanting to do one of their April Fool's jokes that was going to be an actual game. And in the process of developing, they had a management shakeup, and it ended up getting canceled. So I'm going to take the work I've already done and turn it into a separate game next year. And when you're coding for the systems, one of the things, why do people want to write games for the old Atari 2600? And it's more because of the challenges of writing it. There's only 128 bytes of memory, compared to like the PlayStation, which has 256 megabytes. There's no video memory. You have a 4K cartridge space, you have a 1 megahertz processor, but the processor is so busy with the screen that you only get a small part of it to actually process your game code. The memory was quite expensive back when they were developing the Atari. So the 128 bytes was about $50 when they were developing the console, which is why they only put that much in, because they couldn't afford more.
Actually, we started in 1975.
75? Okay.
Yeah.
All right, I'm something I had somewhere. I'll have to fix that then.
That's okay.
And
It's so far.
right, so far back. Right, and there's no video RAM, but the TIA, the television interface adapter, it's scanline based. And it can handle 2 players, which are known as sprites with modern terminology, 2 missiles, a ball, and a low resolution playfield. And your players, it's basically 8 pixels. It's only 1 scanline tall. And so if you had this sample pattern, if you didn't change it, that pattern would just repeat going down the screen. So your program has to update it on every scan line if you want to get your image to be shown. And it does have some features. You can show it in 3 different sizes. You can show 3 different formats with 2 sprites showing the same image. You can do some tricks to show more than the 2 images. And there's also 2 versions of a triplicate pattern. And then the missiles and the ball, it's just a single bit, one dot. And there's 4 different sizes that are available for it. And you can control the size, and you can also shift it back and forth on each scan line. It's a little tricky to do, But by doing that, you can actually make extra sprites, but you have a limitation because it's only a single pixel. Now, the play field, there's only 20 bits that store the play field. On screen, it's 40 bits. So it either gets repeated, whatever you see on the left side is repeated to the right side, or it can be reflected. And the reflection you would see like in the combat maze, where it's mirror image. For the 4K cartridge space, the original games that were coming out were 2K, and they pretty much thought there would be another system coming out later, so 4K was going to be enough for the games. They didn't put a read-write line out, so the cartridges were designed to pretty much only hold ROM. The CPU, too cheap, okay. Since the CPU has to update the TIA on every scan line, you only get 27% of your processing time left over for doing your game logic. The part of the program that drives the TIA is known as the kernel. I don't know if they actually called it that back in the day, but you did? Okay. And the CPU also has to trigger a sync signal. And the televisions back in the day, they were a lot more tolerant. So if you didn't, if you made the picture too tall or too short, the TV would still show it. A lot of the modern TVs, they don't like that. Like my HD TV, it won't show any of the games. Now, it's just because it's not as, they expect it to be exactly right. So if we have a game here, this is what your TV sees. Up here, the beam is at the top, and it's drawing down. It's about 37 scan lines before you actually start drawing your screen. Then you have the image, and then a little overscan at the bottom before it has to go back to the top. And so, go ahead. This would be your program flow. You have to send your sync signal to tell the TV to go back up to the top of the picture. Then you have about 37 scan lines worth of processing time that you can do your game logic. Then your 200 scan lines or so to draw your screen, and then you can do some more game logic at the end. And so if you're wanting to develop, you're going to need some tools. You're going to want an editor. You're going to need DASM. Stella is quite helpful, and you're going to want hardware to do so. So you could use like Notepad if you're on Windows, TextEdit if you're on the Mac. But I like to use a programmer's editor called JEdit. And what this does is if you look over here, you see these are all in blue. These are your 6507 opcodes. The orange here, these are the registers in the TIA. And the green are comments. And so if you mistype something, the color will be wrong. So right away you can tell that you typed something wrong, and you don't have to wait until you get an error when you try to compile your code. And so that's what I like to use the editors for. And DASM converts the code that you can understand to the code that the Atari can understand, well, that the 6507 understands. And so this is where you would get DASM. I'm going to put all these up on my website, and at the end of the slide, it's got that. And Stella is an emulator that it's been around for quite a while. I was actually involved with it back in the 90s. I used to run IBM's OS/2 operating system, and I maintained the OS/2 port of Stella. And you put your ROMs in, you can play the games, and we also have a integrated debugger where you can actually see the status of the memory. You can look at what's in the different video chip registers, and you can single step through your code, which is really, really helpful. If you have something go wrong, you can have the code stop and then go line by line and see what did it do, what didn't I anticipate. Maybe the character went, maybe your sprite went off the edge of the screen and it caused something to not be compared correctly. And for the hardware, well, you're going to want the Atari. And then there's some solutions that you can take your code to test it on the actual Atari. There's a supercharger, there's a crocodile card, there's a Harmony cartridge. And Stella is really great, but it's not 100% accurate. So you really want to test on the real thing. And Here's an example where one of the more recent tricks that we've learned to make the Atari do is a 32-character text display. And it's Sam Thomas, he's known as Eshu on the Atari age. He's the one who figured out the tricks to generate that display. Stella, you end up with this extra little garbage over here because it doesn't, it's tricks that are so new, Stella doesn't understand how those work yet. And we haven't, we're working with people developing Stella to try to make it work correctly, but we haven't quite figured that out yet. And another thing that Stella is, it's a little more forgiving on your TV timing. If you have, if your sync signal, if you don't send it consistently, like every 262 scan lines, maybe one screen you send it after 260, the next screen you send it after 262, your picture will visibly jump up and down. You'll get jitter. Stella doesn't show you that. And that typically happens if your code runs too long. So if you didn't anticipate how long your code was going to run, if it takes too long, you'll end up having your screen jump up and down. So that's the other reason that you really want to test out with real hardware. Yeah, this is a picture of a StarPath supercharger. This was released in 1982. It was about $45, and they sold games for it on audio cassette. Internally, there's 6K of RAM, there's a 2K BIOS, and there's a program called MakeWave that you can use to convert software into the audio format so that you can load it in. And when I very first started messing with Atari coding, that's what I was using. I would run the MakeWave to do it, but you can't do the larger games like you could do nowadays. And this is because of how it has all that RAM in there, it makes it so you can do a little more with the games than you could do with the ROM. So the Frogger looks a lot better. And this was the versions of Frogger that were released back in the day. The Crocodile cartridge. This is the old serial port down here on the bottom. And it was released in 2005. It sold for $100. And this is the cartridge that I used when I wrote Medieval Mayhem. You use a serial port to load your games into it. It supports up to 512K of ROM and 32K of RAM. And the Harmony cartridge is the current cartridge that's used for development. It's released in 2009. It's still being produced and sold, and you can actually buy one today over at the Atari Age booth. And the guy who developed it, Fred Quimby, he had to leave for a little bit, but he may be back later on today if you want to meet him. And it uses an SD card, and you can actually load up a whole bunch of different games on the SD card, and it will show you a menu to pick which games you want to load. Or you could use the USB to load a single game. And that's really handy, in the Stella in the Stay Frosty 2, I've got pause detect logic, where on the 2600, you can use the color black and white switch, and just toggling the switch will pause the game. On the 7800, which is backward compatible and runs 2600, it has a pause button instead of the TV type switch, and the pause button works differently. And if I load in the game using the SD card, it wipes out part of the memory in the, and you can't tell, am I playing this cartridge on a 7800 or am I playing it on a 2600? So when I was doing all of my testing, I would use the USB to load it up and bypass the menu system. And these only support up to 32K, so you don't get to do the 512K games with it. It only has 8K of RAM. But it does have a 70 megahertz ARM processor inside. And Atari Age has a stripped down version of it that doesn't have the SD card, so that they can make standalone games. Another thing that you can do for writing games with it, there's a language called Atari Basic. If you don't think you can handle the machine language, the 6502 assembly, but if you're comfortable with doing it in Basic, you could use that. There's the kernels typically is what you spend the most time developing in your games, to figuring out how to draw the screen. And the Atari, and it's also the hardest part of it. The Atari Basic comes with a bunch of predefined routines. So if you know that you want two players moving around with a background, you tell it that that's the kernel you want to use, and it takes care of all the heavy work for you. And these are just a few examples of games that were done, that were written in Atari Basic. This one here is Gingerbread Man. It's a little platformer game. This one here is Elf Dash. It was part of the Stella's stocking back in 2007. Now we have Cave In and Seaweed Assault, which is one of the new games that was being released this weekend. And when you're writing these games, you only have a few objects that you can use to create your game screen with. It's not like the modern systems where you can have 60 sprites flying around and it's no problem because the hardware supports it. You only get 2. So you got to figure out how you can use these resources to develop your game. One of the handy things with Stella is it has a debug mode which will colorize everything a specific color based on the object used to draw it. So you can take a look at the older games and see how did they make that game. And so like here's Space Invaders, there's obviously more than 2 sprites on there. So how did they do it? Well, if you turn on your debug colors, you can see that they use that triplicate feature to make lots of, make the sprites, and you can reuse the sprites as you're going down the screen. And then Hunchy 2 is a homebrew. And this is the one where they actually used one of those 1-bit objects to draw all these, all the bells. These were drawn, I think, with one of the missiles. And this one's really cool because it looks like a really, really fancy screen. When you go into debug mode, you find out it's pretty much all the background color being changed as you're going down the screen. And a number of games will do that where things that are like in the distance, like like a battle zone type game, you can get a nice effect, and all you're doing is changing one value, the color of the screen. And nowadays people are wanting to there's a lot of people they want to write for the original hardware limitations, 4K only, and others like to see what can we do to push the system. And I'm in the later group. I'll probably write a 4K game eventually, but I've written a lot of code, and so to me the challenge isn't the 4K. The challenge is how can I make this primitive video chip do some neat stuff. And the guy who did this graphic here, Nathan, he's also the guy who came up with the concept for Stay Frosty. He's done a lot of artwork in a lot of the homebrew games. Things that you can do to make your games better, there's bank switching. They've figured out tricks to get extra RAM in there. You can do a coprocessor, and there's a pretty advanced feature called bus stuffing, which we've done experiments with, and we know it works. As homebrewers, we haven't actually utilized it yet to make something. I'm looking to do something with that next year. And bank switching, a simple way to bank switching is like Medieval Mayhem is a 32K game. And the game is split up into 8 4K banks. And there are special little hotspots in the memory that when the processor touches that hotspot, it switches which bank the CPU sees. You can kind of think of it like you're looking at an 8-page book. You can look at page 1 of the book, you can flip the page, and now you're looking at page 2. It's the same concept, it's just instead of you looking at it, it's the CPU looking at it. And different companies came up with different methods, and we kind of refer to those as a mode. And the Crocodile cartridge, you can actually make a 512K game using what's called mode 35. And some of the other companies came up with different ways where, like, instead of 4K banks, they used 1K, and you could pick different combinations of the 1K. And it's a little bit complicated, but it gives you some additional features or additional ways to make use of the limited resources. And one of the things with the extra memory is, back in the day, you had to have your manual to look up which version of the game you wanted to play. And if you lost your manual, if you didn't remember what version was which, a lot of times people end up only playing variation 1 of a game. With the extra ROM, with bank switching, games were able to add elaborate menu systems so that you could pick your options and you didn't actually have to have the manual anymore. The original Warlords game was a 4K cartridge. Medieval Mayhem my menu here, all the code to drive the menu is 6K worth of code. So that wouldn't have even fit in the cartridge back then. Okay, extra RAM will let you make a little more complex game. You can keep track of a lot more things that are moving around in the but without a read-write line, it's a little tricky to put extra RAM in there. What they figured out was you could use an address line to differentiate between reading and writing from the RAM. And what happens is the RAM will end up showing up in the memory twice. You'll have one range where the memory is the read port, and the other range where it's the write port. So if you access, get location 0, you would read, location 128, you would write. But it would be the same part of the RAM. And one of but it's not compatible with like the increment or the decrement with commands with the CPU because it doesn't understand that it's showing up in two different locations. With the Crocodile cart, you could go up to 32K. The Harmony cart, it's got 8K. I'm not sure how much is available as a resource. The Harmony cart, you actually, the bank switching logic is loaded up as ARM code, and that code has to live in the RAM because the RAM is faster for it to access than the ROM. So part of the RAM is used to do the bank switching and logic. So I'm not sure how much is available on the Harmony. Okay, another thing you could do is you could throw a coprocessor in there. On modern systems, that's coprocessors like your math processors in the early computers. That was one of the coprocessors. And right now you've got the DPC, which was done in Pitfall 2, and we've got the DPC Plus, which is done on the Harmony and the Melody with the standalone version of it. DPC was designed by David Crane. It supports an 8K ROM, basically two 4K banks. There's an extra 2K that holds data, and it never shows up within the 4K cartridge space, but there's registers that you can access to read that data in very quickly, and those are done with data fetchers. And there's also a 3-voice music driver where it uses square waves to do 4-bit digital sound. In order to do this, you actually have to update the volume of one of the sound channels on every single scan line. So it's very, it takes a lot of resources to do it. And it makes your code for your game logic a lot more complicated because not only is your game logic running, but you have to remember every so often to update the volume so that you can get your digital sound. And DPC Plus, we took Fred Quimby, who developed the Harmony. He wrote the driver for the Harmony so that you could actually play the old Pitfall 2 game using the Harmony. And we developed, we extended it, and we called it DPC Plus. So instead of 8K, you now get 24K. The display data can now hold 4K worth of data. And it initially starts out in ROM, but it ends up in RAM. So you can actually change it while your game is running. And I'm using those features in the Space Rocks game. We did a fast fetch mode, which makes accessing the display data even faster than it was possible back in the day. We also support the 3-voice music. If you've tried out the Stay Frosty 2, if you turn up the volume because it's kind of loud out there, you might have heard the background music. And with that one, instead of just square waves, it's set up to do custom waveforms. And the other feature with DPC Plus is you can offload non-kernel processing to the ARM chip. While the screen is being drawn, the ARM chip is acting as a coprocessor to feed the data so that the 6507 can update the video chip. But during the overscan time and the vertical blank time, you can offload all the processing to the ARM chip. You have to make sure it comes back. If it takes too long to run, you're going to end up with screen jitter and stuff. And these are some examples of games that are using DPC Plus. The first one there is the Space Rocks, Stay Frosty 2. The bottom two, Evil Magician Returns 2, that's kind of a sequel to Adventure, and Egg Venture. And the bottom two were actually written in Atari Basic. So Atari Basic can be used to write some pretty advanced games now. And the bus stuffing, Commodore developed the Graduate back in the day, and what it does is there's chips in that little keyboard unit that overdrive the data bus, and if it can work hand in hand with your kernel, you can do super fast updates to the TIA. And we've done experiments with harmony and melody, and we know that we can make that work. We haven't actually followed through and done anything with it yet, but that's on the plate for next year. This is going to be a little code snippet, so I'm not going to go too in-depth on code. It's more of a high level here. But if you want to draw your sprite on your screen, every scan line you have to calculate, am I showing a sprite or am I not showing a sprite? And a typical way of doing it, there's a routine called do draw. And this part of the code here calculates, am I showing a sprite? If not, put a 0 in there so that the sprite doesn't show up. And then these two lines here would do the color. So if you were doing a multicolor sprite, it would take 26 cycles of time. You only get 76 cycles per scan line, so that's a lot of time. DPC, which David Crane developed, shrinks all of that code down to that. And it only takes 14 cycles. So by doing that, you got a lot more time, so you can do things like that 3-voice music. DPC Plus, now this doesn't look very different, but let's see, come on. It's not, there it goes. This here means it's an immediate mode address. Instead of a reading from a 16-bit address, it just reads the value immediately. And with the harmony, we were able to overdrive the cartridge or the bus and make it so that instead of taking 14 cycles, we can do the same amount of process in 10. And bus stuffing drops that down to just those 2 lines of code to draw and color a sprite. And it gets it down to 6 cycles, and you can't get any faster than that. We're going to work hand in hand with the Stella team to make it support that. So that, because it's very helpful to use Stella to do the development, and we'll make sure that Stella supports all of that. And so we're going to compare some different kernels. You get 76 cycles of processing time. On the 6507 process, the different commands, they take anywhere from 2 cycles to 7 cycles per instruction. And so a typical kernel, you might be able to draw 2 single-colored sprites, a couple missiles, and a playfield. And it's going to pretty much take up your whole 76 cycles of time. With DPC, we get to add this here where now instead of a single color sprite, we can multicolor, we can do some music. DPC Plus, each step of updating the TIA takes even less. So now, the left and the right side of the screen, we can make them different. And if you do bus stuffing, you get a lot of extra free time. And there's a lot of tricks with TIA that you can do to make extra copies of the sprites and stuff, but normally you don't have the process, or you don't have the cycles to take advantage of those. So with bus stuffing, we get, we'll have that extra time. Okay, I'm going a lot quicker than I thought I would today. These are some resources for where you can get information. Atari Age is a great site to go hang out. A lot of the developers like myself, people post questions, we'll answer them, we'll show them how to make their code work. Minidig, back when I first started, we had mailing lists, and people would do their development and post their code samples back and forth with a mailing list. Minidig basically collected the best of the Stella discussions, and it's all up there, so it's easy access. There's like the trick that the 48 pixel trick to make very large objects like the dragon at the bottom of the screen in Dragonfire. People figured out how that worked and posted it, and it's all documented. Stella, you're going to want the emulator, Harmony, DASM, The 2600 Programming Forum, that's the specific forum on the Atari Age site. And 2600 Programming for Newbies, Andrew Davies, who's done a lot of 2600 work, he actually started doing a kind of like a book format, chapter 1, chapter 2. And if you go through there, that's a really good place to start to learn how to draw the sprites, how to draw the playfield. And then all the Atari Basic stuff. We got the main site for Atari Basic, the Atari Age forum, where a lot of, I don't know if you saw this, Zippy the Penguin was written using that. That's being demoed over at the Atari Age booth. Random Terrain, this site, he's the guy who did the Seaweed Assault game. He's been doing a really good integrated documentation, so you can look up the commands for the different Atari Basic. And a guy wrote a visual Atari Basic, which is a really nice front end. I can't use it because I'm running on a Mac, but it's written on Windows. But it adds, there's a sprite editor, so you don't have to manually draw your sprite in data statements. You can go graphically draw it with the tool. Okay, any questions? I went through a lot quicker than I thought I would today. Yes?
I would actually like to hear from Rebecca on
Okay.
the comparison of the hardware you were talking about, the hardware that she made when she was copying ROMs.
Okay.
Do you mind if I put you on the spot?
Gee, thanks. Well, when I was doing Atari development, which was back in 1978 to 1982, my first professional work was out on Hill. And I developed a card fit to an Apple II computer, and I used the Merlin assembler, which is a 62 assembler, to write my code. The card itself was a variant of the Apple II memory card that they had, which also allowed you to have integer ROMs for the Apple II. I reverse engineered how that card worked, and instead of using RAM in it, I used 6116 static memories instead of ROM. And with that, what I would do is I would have Merlin make an ability to do an add-on, so that when you compile the code, it said this user instruction, it executed a piece of code which took the ROM image, bank switched the Apple II, or this card in my Apple II, uploaded my ROM into it. Then I would bank switch it back. I would have this cable which goes to a cartridge I just ripped out, had the 6116 mapped directly into it. Then I turned on the Atari to play the game, because essentially it's like an instant ROM emulator. And I built something like 10 of these cards for Avalon Hill, and we developed all of our Avalon Hill games using the system. And
Cool.
it was because of the system that allowed me to also have another module which allowed me to go take a cartridge, plug it in, and download it in my Apple II, which allowed me.
That was a nice development system because the Apple self-assemblers were nice, and they had, what do you call it? Disassembler built in.
And that was the Apple II disassembler, how I learned that the Atari 2600 was using the 1602. They downloaded the ROM initially, it was just meaningless gibberish, but I just knew I'd put it up in the cartridge, and then disassembled. Was like, wait a minute, this makes sense. I documented it all, and I discovered how, by changing a few values in existing games, and hey, this changed to a color, then I mapped out all the colors, and hey, I just
That was a superior reverse engineering technique to what David Crane claimed that he did when he built.
But that's how I learned 2600. And through that, and of course I also I was running tournaments for video games, and it had nothing to do with me reverse engineering. I was doing it because I couldn't always get cartridges. But my development system was, build the code in Apple II, upload it into the cartridge, turn on the Atari 2600, played it. I would do little itty sample routines, then sample, because I didn't debugger, nothing like that. So I found that, hey, this was drawing the maze the way I wanted to, and I kept building it up until we got the initial maze display for, we call it now London Blitz.
Okay.
The development name is UXB.
Okay.
So I still every now and then keep thinking, well, I was working at UXB, no, Flooded blitz. But, but then later on, years later, I wrote an Atari emulator.
Okay.
Which eventually competed against Stella. It
Oh.
was the basis for a game called the Acrogen Anthology. From
Okay.
Acrogen
Yeah.
2002.
Mm-hmm.
But part of that development is I wrote an extension to Visual Studio that allowed me to write 2600 code.
Oh, cool.
And then when it was done building, it would create a WAV file.
Uh-huh.
And I double-clicked on that into a StarPath supercharger
Right.
and played the game.
Yeah, that's how I was first initially doing stuff.
And that is how I was doing the emulation code testing for the Acrogen Anthology. And I still have that Visual Studio plugin. So, yeah, I should give it to you. It's for Visual Studio 2005, 8, and I updated it to 2010. And just let you build right code. So did I used to work with Microsoft too. I work on it now.
You escaped.
Yes, it is. Then I
Cool.
worked for Sony for a year.
Cool.
On the
Congratulations.
machine that now just got released.
Cool.
It's for yes. Downtown.
Cool.
I know this guy too.
Yeah.
I know this guy. Yes.
It's like a big read.
Right.
But yeah, I was doing all the stuff back in back in the very early 80s, but the thing that's really that people really raise their eyebrows on is I had no documentation.
Right.
Nothing.
How do you figure that out?
I
Yeah.
figured it all out on my own.
That's impressive. Yeah.
And then I taught everybody
Right.
Avalon Hill, so all the games that were developed by Avalon Hill was my emulators, my background.
That's cool. Yeah, because nowadays, like if you go to that mini dig site, there's the original documentation for the Atari there. So all the, it's very easy to get all that information now.
Speaking of which,
Yeah.
my copy of the programmer's guide was scanned and it's on the Atari partition using.
Oh, cool.
These are people using that.
Well, if you want to have some real fun, to see my just assembly skills, Google freeway.assets. It is a complete line-by-line disassembly of the game Freeway by David Crane, which I
Yes.
made specifically from ROM with no documentation and is indistinguishable from original source code because everything's documented, every single line. It's freeway.asset. There's a website, I think it was Atari 8, self-hosting.
Okay.
But I was the one who wrote that.
Cool. We got any other questions? Yeah?
Could you explain a little bit of the mechanics of how bus stuffing works? And I got what the benefits were, but I think I missed something.
I don't fully understand it, but I think how it works is like if this internal CPU puts out at 255 on the data bus, which is every single bit of the 8 bits turned on, that something else connected to the bus, I think, grounds it out, which turns it to
Yeah,
zeros.
this works if you've got NMOS device driving the bus, but not if you've got CMOS
Okay.
driving the bus.
Yeah.
And the 2600 was in completion of NMOS.
Okay. Yeah, and it's and we've only done experiments to show that it works. Like John Payson, who wrote the Toy Shop Trouble game, that was one of the holiday carts for Atari Age. He's done a example which has a whole bunch of sprites going across the screen, and they're all different colors. It's really slick looking, but it's just a static demo. So that and we use that to test that yes, it does work.
I actually did bus stuffing in TV2 or Time Warner on a play cable system.
Oh, cool.
So yeah, I know how it works. It's where the ROM is, there's lines for the address bus and the data bus. It's like, I remember it was 12 bits, previously. What goes on is as the processor is running, it can see whatever the instructions are it puts on a data bus. So let's say A5 is store X. Still remember that. So if it sees the number 85, the processor would use a store X instruction, which means it would be followed by an address of the 0 page, and then be followed by the write. So 3 instructions. 8.5, an address to write to, and data to put on the bus. The way data stuffing works is that the cartridge would actually be monitoring as if it was a CPU, and say, oh, instruction, ignore the next 2 writes. Oh, instruction, ignore. So it's just simply monitoring. But when you go into a specific mode, I would then say, I am now going to bus stuff. Anytime I see an 8.5, I'm going to wait 2 cycles. So change data, read that value, whatever. Change data. The code in 6802, you have to do load X with FF. It has to be writing FF. That's only 0 off the buttons. So I loaded X with FF. Wait until that precise moment, and when the FF goes on the bus, the cartridge actually writes out zeros and all the bits that it wants to override. And then therefore they cancel each other out, and what really takes precedence is whatever, the zeros win. And which of course, because the processor is putting out FF, meaning I don't care, they're all gonna lose, the cartridge puts out whatever values I want. I then have the instruction say, store X, whatever value it is, so now the TIA is going to be at this address, so it's going to be right in that register. The cartridge that shows out the value overrides, so now the CPU can say, store X at 3.6, so store X at this register, store X, and the cartridge is saying, okay, show this value, show this value, show this value, so there's no load instruction ever done.
So it's kind of a man in the middle attack.
It is. It is a method. But because of this technique, it
That's a
allows.
little contribution.
There has to be some contribution, because if X is not FF, then those bits will also lose. So if the cartridge writes at 1, the whatever is being written. So you can actually get even creative in which you can have the CPU have some contribution to what's being written. But that's the technique. What I can tell you is that after leaving Avalon Hill, I went to work for Time Warner. I was there for about 3.5 months working on a play system. We were going to do a set-top box that lets you play Atari video games downloaded off of Time Warner's video system. After the television system was announced, we canceled the project. Part of the proof of concept is I designed a board that would plug in, has the 80 processor in it, and uses bit stuffing, and I had a text screen that lets you use the Atari as a text terminal. And I was using bit mapping the whole screen using bit stuffing. And that's why I look at this as a technique quite well.
Cool.
So we reverse engineered the system. I had no doubts.
Do you mention the Commodore developed the keyboard? Or-
Yeah, they actually, I think they called it they like made a spin-off group. I think it was called TVI, and so that it wasn't. And then they went to work with Atari, and they had started to develop it, and Atari kept adding more and more requirements to it, and eventually it became too expensive, and then it just never came to be.
Sometimes you need to shoot the market.
Yeah.
This is what Commodore developed their Commodore system.
I think it was later. I don't know the exact time frame. On the Atari Age site, somebody had posted a site that has all the information about it. And there's actually, there's a large PDF you can download that actually has all the bus timing for the bus stuffing and stuff, which I don't actually understand. Yeah, because that's not my expertise. But if you if you go to my site, thespiceware.org, my email address is on there. You can drop me a note, and I can send you a link to where that information is. Anything else? Okay. Well, I guess we're done then. Thanks, y'all, for coming.